start the time it could be to try out the language. So just going to go with the words I know. So yes, so here we are. Thank you for attending this session, and I'm so excited. It's my first time in Istanbul, and that too for a Java conference, something I am very close to, and it's also very close to my heart. I'm really excited for this. I can't express how much. Really excited. I also have a flight to catch, so I'm hoping that I'll be inside. So this is what we're going to talk about. I'll read it out in a bit, but I'm sure you already saw the agenda for the day, so you already know. My name is Abhirami Sukumaran. You can address me as Abhi. I'm a developer advocate at Google. I predominantly focus on Google Cloud databases and their data to AI journey. I have over 17 years of experience in software development and also particularly in building applications for data to AI in the data management area, master data management, analytics, and now by extension generative AI as well. I'm not a data scientist. I'm an application developer who focuses predominantly on databases and their data to AI journey. But now we all know there is no one, but it's not just a data scientist who focuses on AI or generative AI anymore. That's one of the things that we'll talk about today. And also I recently published a book called Database Design and Modeling with Google Cloud. So if you get a chance, and if you're interested in databases too like me, just feel free to try it out and let me know what you think. Let's get started. So imagine if there was a time when I hated starting any talk with imagine if, but now I'm just being a simple hypocrite. Imagine if, as a software developer, with some lines of code, you are able to connect to a cloud database with organizational data that has knowledge about any customer for that matter, right? For the organizational data, for your company or your customers' data. And instantly you have to create a cloud, or you have to just create a chat application or an assistant that is capable of answering user questions, customer questions, or you have to build a summarization engine that is able to translate complex reports, or even draft marketing emails. How cool would that be, right? And all within the scope of bringing data to AI within the scope of your applications, your web applications that you're building. So that would be really cool, and that's one of the ideas, probably some of the ideas people are thinking about nowadays. And it's not fiction right now, right? To pull something like this, pull off something like this right now, the data and the tools that we have is pretty straightforward, or at least that's what we think. Idea-wise, we have so much innovation going on. It's not fiction anymore. It is the power of bringing data to AI within the scope of applications. But just like me, I'm sure there are a lot of you who feel like, I have all these great ideas, but for some reason, either there is a starting trouble, I don't know where to start, or lack of time. For instance, you're juggling with a lot of day-to-day deliverables and you don't have enough time to focus on this kind of ideas. Or for that matter, sometimes you might not have the resources or the starting point, like I said before, to build something like that quickly because of the conventional approach or the conventional amount of steps or just the amount of steps in our minds in order to accomplish something like that. So we just drop the idea, or we just get on with our day-to-day deliverables, or we try to incorporate that onto our day-to-day deliverable and spend a lot of time in that meeting to complete that. If that resonates with you, great, I like that too. Sometimes I used to have so many ideas that I was not able to work on until I found out a strategy or at least an approach to get things done really quickly, or at least I learned about some of the tools that I'll be discussing today, which helped me greatly, at least get 70% there with all my ideas. Right now, I just have a couple of ideas, one which I've already implemented, and one still in my mind, which I've not got into implementation. But apart from that, I'm trying to complete everything that I had in my mind, or at least write about it, done what I needed. Just one more thing, and I think I'm just postponing this because I had a lot of travel coming in. So that's how simple it has made my, at least my ideas, from an ideas perspective, translating or rolling out my ideas into implementation. So I'm going to share with you my experience with some of the tools that have helped me greatly in achieving that. So I'm hoping it'll be useful for you as well. Of course, Java plays a big role there. I have used Java as my primary programming language for all of the applications, most of the applications that I've been. Sometimes I use Python to, stay with a friend. And nowadays you can't complain. There's all the generative AI libraries and other things that come in. They first get released in Python, and then other languages catch up to it, like client libraries. I get annoyed by that, but we can't help it. So sometimes I do it first in Python, and then I make sure it's made right and it's delivered right for Java as well, at least as much as I can. I at least complain about it, even if I don't solve it. So that's what I do. So just a little bit of expanding on the problem statement. Not very, this is not a problem, by the way. This was a much simpler time, or at least not a less sophisticated time, I would say. Not very long ago, although they may just take us back to I shall go old times. But not very long ago, although it seems like very long ago. This is the style of building we used to do, right? Applications and database. Of course, it's not that simple, but it's fairly simple-minded, bringing your organizational data and your applications. Of course, you use frameworks and tools and ORMs and all in between to get it done, but the overhead, the weight lifting of other activities like operations, administration, analytics, AI, those were their own problems. Those were their own needs. But now that's not the case. You can't just separate generative AI from your applications, right? So this is where we are right now, because with the rise or the advent of generative AI, at least the last part of years or 2 years, we have been put into this, not put into, it's a good opportunity also. We've been getting these ideas because generative AI is able to augment, it is able to orchestrate information and stitch it with the, basically to stitch domain data with your application, right? So that is the power of it. And since we are able to do that, and we also have to do that, it is not as simple as before, which we saw. It's not straightforward as just plugging your application data to database. What existed as silos before, for certain good reasons, now have all combined together, also for good reasons, but now we have to focus all the more on what is there a template for it? How can I bring the pieces together and get started and start implementing my idea of translate the organizational data into an application or chatbot or any kind of application like that with generative AI. With the use of generative AI, or generative AI being a core component of it. So how are we going to achieve that? Now, if you talk about generative AI, any app development without generative AI as a main part, or AI as a main part, it's almost like a crime. Okay, I'm exaggerating a little bit, it's not a crime per se, it's not against the law, but come on, we have to admit it's just way too much. It's everywhere. Everyone talks about generative AI, everyone talks about AI. So you can't really talk about app development now without talking about generative AI as much. So it has become, in the last 2 years, a core component. Although, what is getting lost in the details is the actual detail of what it takes to build such an application at such a scale that we are talking about, right? So, we are going to see some of the approaches or templates or some strategies that I use or the tools that I use in order to this is also, there are some strategies, some templates, and also you can craft it the way you want. You can take the pieces that you want from it and you can build the way you want. But of course, I'm going to share one way that I did it. But also, this is a standard way or standard approach of how we solve such a problem or how we solve such a solution or such an application. The 3 P's, proximity, platform, productivity. Proximity is bringing your application and data closer together. Right? So thinking about AI implementation or thinking about writing separate Java code or entirely separate Python application just for the Gen AI part and doing the database in a separate application, those times are gone. We want to bring the data and the AI part or the generative AI part and the application close together, which means your database, the operational database that you're using should be capable of doing most of the weightlifting of generative AI parts for you. Please, you will have to think about, how do I convert this into vectors? How do I do the vector search behind the scenes? Should I call a separate API in order to convert it to embedding? So should I call a separate, should I write a separate function and deploy it on the cloud or save it somewhere so I can call it for vector search? So you shouldn't be doing all those things. Make sure your data and your applications and generative AI are in close proximity to each other. And then platform, of course, you want to leverage a fully integrated platform which supports apps, APIs, and your data, which is also the LLMs, right? The large language models. Of course, productivity. You know how, I don't know if any of you have tried Gemini for Code Assist, Gemini Code Assist or Gemini in databases. and other Gemini tools that allow you to improve your productivity in support of when you're actually writing your code is Java application, or you're writing database queries, or in some cases you will be thinking about, I want to deploy this, I just have a function, I just have a one-page code, or I have a big application that has too many dependencies and integrations. I want to deploy it serverlessly really quickly. What are my options? I'm new with Google Cloud, so what are my options? Or this is how I want to do, I'm new with Java, or I'm new with Spring. What version do you recommend? Or what kind of libraries do I need to include if I want to use Vertex AI from Spring framework? What is the Spring module that supports Vertex AI for Gemini? You can ask questions like that with the Gemini chat, and you can actually make your development process fast. You can make it actually make your job more productive, and you can use generative AI tools, which we'll see in a bit, hands-on, so that it helps in your development process. All right. So now we are in a much better place. You think. We have application databases, and then we have foundation model LLM. So what's the problem? You said you have proximity covered, so we have all these things. So what's the problem, you may ask? So that's where we wanted to talk about this, because, oops, where did it? I could have stick them on. On. All right. So here. Not that it's not accurate might not be the appropriate word here, but then with LLMs, of course there is generic information out there, but you want something that is very specific to your business, very specific to your customers. Sometimes you want more up-to-date and precise answers, and more deterministic answers, and consistent answers every single time you ask that. And you may want it in a certain format, and you may want to do some validations, so on and so forth. So you want that accuracy and being up-to-date. And also contextual, which is what I said, contextual user experience, not just by generic language model or generic knowledge that's available out there. You might want your applications to work specific to your business or your specific domain, or to the context that you're working on. Maybe one use case where you're supporting a publishing company, or where you're supporting a news channel, where their style and way of headlining or captioning a news blog might be completely different from a LinkedIn caption, right? A LinkedIn caption, you put emojis and be like, today I'm just doing this, I'm announcing my new title or something like that. Whereas in a news headlines, it will be like, you have to be more empathetic. It has to, I mean, we would think so, but we don't know what happens. Excuse me. And then we have to be domain specific and context specific as well. And finally, it has to be easy to build and operate. And that is where we want to use the power of data and applications, bringing the augmentation between foundation models or any large language model for that matter, or generative AI using data augmentation is exactly what we want to talk about. So it is not just applications, database, and your LLMs. We also need the augmentation part. So that's the piece. That's the missing part, and with that, we will get into some of the ways we can approach this kind of an augmentation with data in your application. How many of you are annoyed with the term prompt engineering? Too much about prompt engineering, but it's a big deal though. The way prompt engineering is, if they call it out these days, it's like, oh, it's too much. I've had that too. I've seen so many posts talking about prompt engineer for this particular experience. How do you get a prompt engineer with 10 years of experience? We hardly knew the word even before 2022. We know what prompt is, but that's just an English word. Now it's a phenomenon, right? It wasn't like that. So there were opportunities like that, which, to be honest, annoyed me too. But there are reasons we need to productionize. Think about productionizing applications, right? You're not always prototyping. You're not sitting there and typing just a prompt and getting responses. You want to productionize it. You want to version your prompts. You want to design or define your prompt management strategy. There's so much to it. I can talk about just prompt engineering for 1 hour with hands-on productionizable code and implementation, but that's not what I'm going to do today. But just know that is one of the ways you can do this augmentation. But the problem there is, it also, again, prompt engineering is where you specify your prompt, you do everything, but still there could be inconsistencies, there could be inaccuracies. When I say inaccuracies, context-wise, so those things could be there. Again, you need to have the data to give right examples and all of that. The second method is fine-tuning. How many of you know fine-tuning here? What is fine-tuning? Yeah, so you could by fine-tuning is a traditional method of, think about supervised machine learning job. right? It's just giving the data and training the machine to do something, but in this case, you're giving the data and training the model that is already built to do something specific, like I said before. For example, a news channel wants to use the large language model that is generally built for any use case. You will fine-tune it with that news channel specific data, and you will build that trained model. So, long story short, that again is a good option too, but it comes with a cost. Of course, you want to train, you want to give that data, there are resources associated with it. So, of course, it is a little bit cost involved as well as compared to the last method, which is RAG, retrieval augmented generation. It's the three, if you want to understand it as the three English words: retrieval, augmented generation. Retrieve the data from the database, augment it, massage it, and do the proper data management activities, basically augment it with additional information, and generation. Use this as a source for generating using the generative AI models, right? So that's what RAG means. Basically, use your organization's data and use anything that's supportive in terms of ethics and make sense out of it and make the model work for you. That's what RAG stands for. Compared to the other two methods, this is a little bit more cheaper, and also it doesn't mean that we always want to do this. Some organizations use a combination of these three as well, or a combination of these two as well. Moving on. So this is what we're going to see in the demo today. I'm moving on to the demo right now. So we will have retrieval augmented generation. So I'm going to take an example of paid search. I'm going to build a Java application. Majority of it will be the database part and the use case part, which is basically how many of you are fed up with keyword search and you want to search based on meaning, right? You just want to think about something. I just want to do search or by NLP, or I just want to search by machine learning or something of that sort, and I want the engine to understand, the machine to understand not just by the keyword, but anything that relates to the idea. Maybe NLP or ML, just very generic. Let's say I'm thinking about building an NLP, or I want to submit a patent for a new NLP idea, which just listens and which listens to some language that it's speaking, automatically translates it, and then augments it with information that's available on the internet, and then translates it to image and propose it. The solution is not an idea, but I'm just saying, let's say this is my idea. Now I can type this in my patent search, in my application. The requirement is I should be able to type something like this in my patent search application and ask the machine to find ideas that are already presented, or already patent approved, or already submitted by other folks, even remotely related to what I have presented as a my idea, right? Not just by keywords, I want it to understand the meaning and ripple up everything that are related to it, right? So this is exactly my requirement. So that is the use case. So that's my question. And what I'm doing is I'll search the database, retrieve the top few that are matching, and then I'll generate the answer. But now I'm using LLM here to convert data into embeddings, and I'm behind the scenes using vector search, because that will help me search faster, and it will help me search by meaning and context rather than just searching by keywords and just words, right? So that's exactly what we're going to do. How many of you know what embeddings are? Right? So most of you probably already know, just like I was trying to say hello when you're probably trying to raise your hand. I'm not going to ask any question, don't worry, you can chill. Already, there's too much to make everything that I'm saying and think I'm boring, but still, I'll continue to, I'm just asking to understand whether you're liking the generative AI topic, what's like, what's Java, and I'm familiar with Java, hold on. So, anyway, talking about embeddings, it's just a numerical or vector float array representation of your data. It could be text, image, video, audio, anything, you name it. The numerical or array of floats, it's an array of floats basically, vectors, also a little bit sophisticated numerical representation or a float array of the data that you have is what we call as embeddings. Now, why do we convert it to embeddings? So that the wax of finding the nearest neighbor is faster, right? So that's it. That is why we are doing, and that's that process of searching the nearest neighbor for embeddings is called, what is it called? I said it already. Vector search, right? So that because it's a vector and we are searching for a vector. We are searching for something that's closer to the vector, right? So we are going to use that, and that's what you see in this particular image. Now, I'll skip these two because I've explained pretty much. I'll just dive into the demo. So this is what we're going to demo right now. We'll set up the database first, and then we'll create extensions. So before going into that, this was important, the previous slide. What technologies we are going to use for it. Just so we are aware of the technologies we are going to use for it. Why? Sorry, it's not the clicker that's wrong, it's me. I just keep pushing the wrong button. Okay, so what are we going to use for the app? We already know. What programming language are we going to use for it? Java. Not just. I'm also going to use SQL, right? It's not a programming language per se, but you know how easy it is if you're able to do all of the heavy lifting in just queries, all the database part, data part queries, and focus on application development in Java. It's so simple, right? So that's what we're going to do. And then what database I'm going to use? AlloyDB. I'm going to use this Google Cloud database AlloyDB, which could be both transaction and analytical database. It's super fast, it's high performant. I'm a fan of it because of how fast it is. I have to be honest, it's actually very decent compared to other Google Cloud databases like Spanner, Firestore, Cloud SQL and all that. I've always been a fan of BigQuery. But with the AlloyDB, I was a little bit hesitant, like, man, it's like a blue-eyed boy that Google Cloud database was. I'll just give it some time. But when I started implementing it, the speed just impressed me so much. I'm building everything with AlloyDB. I could pick any database right now, but I wanted to do it in AlloyDB because it was so much fun. And in just not even a minute, it's a few seconds, I was able to update evidence really quickly just by using SQL queries. So that was really impressive for me. So I'm going with AlloyDB right now for this use case. And embeddings model, we are going to use Google Cloud's Vertex AI service. We are not going to go into Vertex AI at all. We are going to do all of this in just apps and database because all of Google Cloud databases are empowered to interact with Vertex AI, which in other words, all the ML, AI, and generative AI models of Google Cloud remotely from their respective databases itself, which means you can talk to Vertex AI models or Gemini, the large language models, only using SQL queries from database itself, just by giving it permission. So you will see that as well. So I'm going to use Vertex AI. It's the one-stop shop for all machine learning, AI, and generative AI needs in Google Cloud. So that's what Vertex AI is, if you haven't heard about it before. It's a service. You can go to Google Cloud Console, search for Vertex AI on the search bar, and you just go into it and look at all the models that you want to play around with. Click the documentation, you will see code. You can just use the code as this and have a starting point for application. We are not going to do that today. I'm just telling you in case you're curious of Vertex AI. The next thing that we are going to use is Cloud Run. So we want to do quick development, right? I said that you need a starting point. So I'm not going to do like a lot of development and wait for it, set up another server and do all those things. I just want to write commands, Cloud Shell commands, and make sure the code that I write goes to cloud in just one command in under a few minutes or few seconds, right? So I'm going to use Google Cloud Serverless Services. Here I use Cloud Function, which behind the scenes also uses Cloud Run. Cloud Run is for more, so it's more big applications that are having a lot of integrations, a lot of packages, a lot of dependencies, so on and so forth. Here I use Cloud Functions. It's a one-page application that I'm going to use, so it's fair to use Cloud Functions for this. There's the same thing, both serverless with one command we deploy. We'll see that right now. So that's why I wanted to show this. And with AlloyDB, like I said, we are going to set up extensions. So Postgres, how many of you are Postgres users here? Wow, okay. So AlloyDB actually has direct support for Postgres, right? If you know Postgres, that's exactly what the same experience that you'll be getting. It supports Postgres. AlloyDB is the support of Postgres. And PG Vector is what exactly we are going to use. We are going to enable that extension from AlloyDB as well. So what we do is set up the database, set up the data and everything, create extensions. Two extensions we create, one for PG Vector and one for accessing all of Vertex AI models in AlloyDB. So we create those two extensions. And finally, we'll bootstrap our JavaScript application, simple standalone application, and then Java application, and then we deploy it and we test it out. Right? So the QR code is for the Medium blog that has all the steps that I'm going to show right now, so in case you want to try it at your own time. And the GitHub repository is also linked to the blog, so you don't need to copy both. I just posted the link and the QR separate.
Okay. So,
This is what the blog looks like. I already showed you the overview of this. Why we already discussed the proximity, productivity, and platform. And finally, once you go to Google Cloud, you'll have to enable the APIs because you need to consciously choose all the services that you want to use in Google Cloud. So you will be, if it's the first time you're enabling a service, it will ask you to enable it for that particular project. So what all do we need? Clearly, we need a LoyDB, we need Cloud Run, cloud functions, basically Cloud Bins, all those three are related to cloud functions. And then you will need, that's it. So those are the APIs you will need. Even if you miss it at the beginning, in the course of development of the application, it will prompt you to enable it as and when required. So don't feel stressed about enabling all the APIs right at the beginning. Okay. Let's go ahead and create a LoyDB's cluster, instance, and database, and the table. So for saving some time, I've already created the cluster and instance. So this is what Google Cloud Console looks like, right? Just go here, do console.cloud.google.com. and search for whatever you need here. In this case, I want to search for a LoyDB. It opens up like this. Currently, this lists all the clusters and instances that I have. I click that and I already have this open right here. All right, you can also create your cluster by clicking create cluster. It's fairly straightforward, just a few steps, point and click, you're done. All of these things that you're doing through the console are also available for you to do programmatically, also through Terraform scripts, also through Cloud Shell commands. So the console is just for convenience, just for when you're building your applications yourself. Later, when it goes to production, of course, you know the drill, right? All right. So now I have the instance, I have the cluster, I have the instance. I'm going to create the table, right? The painted state table. So this is the table. You can copy that from the blog as well. I already created the table in preparation for this, just this warning. So we have the fields, ID, type of patent number, the country from which the patent was submitted, the date of submission, abstract of the patent, which is really cool. I mean, so this data set is from BigQuery's public data set. So if you go to BigQuery, you go to public data sets that are available. If you're building applications for prototypes or for demos or even for understanding some data that's available there, go ahead and play around with the publicly available data set. There's lots of data, a lot of really nice, interesting use case data sets that are available in BigQuery. So I picked this from there, the patents data set. So I could see the abstract for some of these patents. These are okay for you to use for, I think, prototypes, educational purposes. Just read the license, but yeah, you could use the database for demo purposes for sure. And it has the abstract, it has the title, the kind of patent, the number of claims of the patent, file name, and whether it's withdrawn or not, or something of that sort. The table is created. If you want to look at what the data looks like, we can always run a select start from all the patents data. Oh, it was right there. There is this. I'm running this query again. Not sure if my internet is supported. Oh yeah, it's okay. Okay, we have, this is the kind of data that's available for us, right? So as of now, embeddings is not there, it's just this data, and the abstract lists the abstract of the patent itself, and there is a title for each patent as well. All right, what is the second step I told you? We have set up the database and everything. Now we want to create extensions. Just simple DDL commands, if you know DDL, data definition language scripts. Just create these to create extension vector, create extension to with ML integration. Right? The first one is for using PG vector, the vector search, and second one is for interacting with Vertex AI APIs, models basically. And then we have to execute on function embedding to Postgres because we want to invoke. So Postgres is my user date. It's not referring to the database here. I just came to Postgres. But yeah, basically here you're just granting just another database run where you grant execute permission to the embedding function. Alright, so all this is done. Now I'm going to alter this table to include a column abstract underscore embeddings because I want to convert the abstract of the patents data into embeddings and store it. So when an end user is doing real-time search on context, it is able to convert that to embeddings in real time and compare it against this, right? So that's why I want to store it. You may be wondering, why did you create this in the table in the first place already? I did not think it through. So I created it later. So I altered the table and I added this column, abstract embeddings. Vector size 768. This is the standard one. If you feel the need for a different dimension for your vectors, go ahead and change it. But I've tested it. This is pretty much work for most use cases, 768. All right, now moving on, we have all our database objects created. The DDL definition, the data definition is done. Second step is also contains inserting data. So what I did is I went ahead and stored this data from BigQuery dataset, which I used. I created insert scripts for that for you to use also when you're trying it hands-on if you are. So I just took all this data from here. I just ran it in a LoyDB. It's a LoyDB, and like I said, it's lightning fast. So in just a few seconds, it was able to insert the data as well. If you test it out, I'm not lying about the insert timing. It didn't even take a few seconds. It inserted this morning. Moving on, so I have the data right now. That's the data that you saw before. You didn't ask me where did the data come from. You just created the table, right? Are you sleeping after lunch? No? No, okay. I just skipped a step there, so I went back and I told you I just inserted the table, using the DLL statements right now. All right, moving on. Now we want to make a LoyDB talk to Vertex AI. So this is just a regular one of the step where you take the service account. So how will you do it? Go to Google Cloud Console, like I said before. Go to IAM permission, right here, identity and access management. Search for a LoyDB here at permissions tab, whenever it's ready. Correct. Click here, grant access. Search for probably a LoyDB. It will list the service account that is associated with it. Select it and provide Vertex AI user role and save it. That's it. So again, like I said before, everything that you're seeing here are programmable, or also if there are scripts that are available if you want to plug it in a production system. This is just a console way of doing it. All right, so now that all of these steps are ready, let's go ahead and test the embedding function, right? We want to test how LoyDB is able to take the data and convert it into embeddings. I'm going to copy this query from here in the blog. I'm going to run this from a LoyDB right here. I already have it here, so I'm just going to run this. Run selected. I just want to convert this text. LoyDB is a managed cloud-hosted SQL database service. That is a text I want to convert to embeddings, and this is what it looks like. All right, but just like I said, it's an array of flows. That's all we did right now. Now moving on to the next step. This was just to show that everything is done, the embeddings are generated. Moving on, we want to update the abstract embeddings for all the rows. We just tested if it's working for some random data. So go ahead and copy this DFN statement, which is update payments data. Set abstract embeddings equal to calling the embedding function. Remember I said you can just do all of this using SQL queries from a LoyDB itself. That's what you're doing right here. Embedding is a remote function which internally behind the scenes calls the embeddings column from Vertex AI. How does it know to do it? Because we actively created the extension, right? The PG vector extension, and we enabled the other extension to talk to Vertex AI, so that's how it knows it. So it is able to now run this update statement and update all the rows in the table that you just created with the corresponding embeddings values of your abstracts. Alright, so I have executed this statement already, and that is what you see here in patents data table. Let me show you that.
The theories and treatises and their study of the CNN, only to throw on you and give in. Which is in the detail for you as a giver.
Okay, here we go. So we have all this data. Previously, what we did not have is abstract embeddings. Once the update statement is run, you can see that all the rows contain their corresponding embeddings for the corresponding abstracts. Alright, so we're good with everything. What is the last step to do? Test if the similarity search is working. Not just test, we want to write a query to find the nearest neighbors. So in this case, I'm going to use the mathematical cosine distance or cosine similarity. Cosine is never a distance, it's always a similarity. So there is a difference. In other mathematical methods, you will actually find the distance between two texts, whereas in cosine similarity, you would find how close two texts are with each other. So I'm going to use the cosine similarity method. So just copy this SQL, this select query from here. I'll explain this right here, what this query does. Just go right here. It's actually I'm concatenating the ID and title as literature, and I'm taking the abstract from patents data. I'm ordering by abstract embeddings, and what I'm doing here is this sign here represents cosine similarity in a LoyDB. This symbol here represents cosine similarity with the embedding of the real-time text. So as a user, this is the text I'm searching on. So what is my new idea? A new natural language processing related machine learning model. That's a lousy idea, but that's all I could come up with at 4 a.m. in the morning. So just deal with it. So a new natural language processing related ML model is my new idea that I want to search the patents database on. So I'm converting this into embedding and I'm doing a cosine similarity on the existing embeddings. And let's see what happens. Okay, the result was right here already. Okay, do you see that? It's really quick. See, that's all it took to do the cosine similarity. The top 10 closest matches. As you can see right here, it has taken everything from the top 10 that are close matches to the search text, which was lousy. We can verify. As you can see right here, it's taking voice signal, converting voice signal into information in a text form, and something that is contextual language and natural language expression. And the next one is identifying words. So it's all pretty much related, right? It's contextually related, which is a good thing. That's all I wanted. Now, for the most important part, the start of the evening or start of the afternoon is building the web application for it in Java. So, if you have not used Cloud Shell Editor already, this probably will be useful for you. So just go to Google Cloud Console, right? As we saw right here. So this is what, once you land, this is what it looks like, the dashboard. On the top right corner, you have something called Activate Cloud Shell. Go ahead and click that. Once you click that, you will be able to see the Cloud Shell terminal that you see right here. I'll close this, because I already have it open, and reconnect, all right? So I have the Cloud Shell Editor open right here, terminal open right here. This is a virtual machine, which is a Cloud Shell machine that comes with two things, editor and terminal. Editor is for you to write your code. It's very similar in experience to VS Code. You can compare it with any editor that you use. It has direct integration to your versioning system as well. GitHub source control as well. And the editor where you can write code, right, which has integration to the source control, like I said before. So what I'm going to do is I'm going to go to the Cloud Shell Editor. How do I navigate to Cloud Shell Editor? Once Cloud Shell Terminal opens, just click the pen icon, Open Editor, and it toggles between Editor and Terminal. I feel comfortable opening it in a separate tab. You can do whatever you want when it comes to this. So I'll show you how to bootstrap a quick Java application, Cloud Run or Cloud Function, depending on what you need. So this is what you land on. You will land on your root folder. I'm going to click the project name in the bottom left corner of the status bar. It opens up Cloud Code Projects. What do I want to do? I want to build a new application. So few applications. What application I want to build? Like I said before, Cloud Functions. So click that. What language? Java. Hello world. I want to name it, say you can name it as Gemini Alloy DB or whatever you want to call it, and hit OK. It takes about a few seconds and it bootstraps the application. Right now I do not have enough space in my sample project, so because I have too many projects open already. So it's not opening the template, but whenever you try and, it takes a few seconds, just split seconds for it to bootstrap the entire application. So I have already bootstrapped it in a different profile. What I use right now is my personal profile, which doesn't have enough space. I've way too many projects distributed this morning as well. So yeah, so the application is bootstrapped. So now this is my bootstrap view of the entire project. This is the project structure. So I've created the project, the alloydb-gemini. It has the pom.xml, which we are going to edit right now. So what do we want to do? We want to download include all the dependencies. So you can ask Gemini right here. You can ask Gemini from your Cloud Shell terminal itself, what are the libraries that I need to include, or what is the version to include Vertex AI in my pom.xml, right? Okay, it's not connected, so clearly it's not going to work. But this one's not connected either to not real time. But anyway, I'm walking through the course, but when you're connected, just click that and ask your question. It will be able to give you the libraries and all the dependencies that you need to include. So in this case, I already asked him and I already have everything I need. So I have AlloyDB JDBC connector. I have PostgreSQL because I said it is compatible with Postgres, binary compatible. And then you have the JSON for handling your JSONs. And as you can see right here, I've committed one thing, which is the Spring module support for Vertex AI Gemini. The reason is this is an extended implementation which you can do after this session if you like. I have not extended it with Gemini. I've only used vector search. The Gemini, the Vertex AI's embeddings and vector search. But you can expand all those use cases and build more. But this is a starting point where you expand. So I just left the code right there. I committed it. So this is Spring module support for Gemini, Vertex AI and Gemini. All right, but I'm not using it in the code right now. And now for the main class itself. So what I have right now is, of course, I want to search text, the real-time text that the user enters, and I have all the connection to Alloy DB, the JDBC connector, set up the connection, right? So you have to provide all the details of the cluster, the instance, and the password, all the details that you need to configure. Feel free to use the environment variables, secrets, authentication, and whatnot for any production application. In this case, I've just hard-coded it right here. And then, this is where I've actually included the entire SQL itself. As you can see right here, the same SQL that you saw in AlloyDB where I just wrote the vector search query, I've incorporated that as it is with the search text that is being sent by the user in real time, or in this case, the one that I'm going to show you when I run this application. Right? And then I'm writing the closest match back to the web app. That's it. That's all the code does, nothing much. So now what I'm going to do is in launch.json, just note what your entry point is. This all gets, you're writing all this code except for what I showed you in form.xml, the highlights that I changed, and the code that I replaced in the hello world.java, the main Java applications. Nothing else I changed. Everything else is out of the Bootstrap template itself, right? So I also showed you about the Bootstrap. Sadly, it didn't Bootstrap because it's still not selected. So that's pretty much it. Now, what do I do to deploy this? Like last step. So go to Cloud Shell terminal. All you have to do is, or you can also copy this from the blog. There you go. This is the command that you need. Make sure you're inside the project folder and run gcloud functions deploy. Give a name for your functions. Specify the generation of the function is Gen 1 and Gen 2. Gen 2 is latest, always go with Gen 2. Region, choose whatever region you prefer for your application. Runtime, choose the runtime of your choice. Source, dot to reference that our current active folder contains the source code. And your entry point, which we copied from launch.json. And trigger is HTTP. Trigger is basically, if you write a function, you need a triggering point for it. So basically, trigger is you're calling it through REST endpoints, right? So it's HTTP. There can be other triggering points as well. You can call it as an event, so on. There are multiple options, but I'm going to use HTTP because I have I want a REST endpoint generated and I want to hit that to see the result. Now, once you do that, again I'm disconnected, but once you do that, your function is deployed and you get an endpoint that looks like this, right? It's also there in the blog. The endpoint looks very much like this. The region and your project ID .cloudfunctions.net / the name of the function that you provided. Now, I want to test it, right? So you can test it in multiple ways. Of course, you can also do the Cloud Shell method. So I'm going to go here, copy the Cloud Shell command to test it. So I'm going to copy this. I'm just going to quickly change some things here. I need to change the name of the function, right? To the one that I've deployed recently, alloy-gem, right? So I'm going to change this, alloy-gem. And that's it. Okay, these are all double dashes. This is a mistake. It's not a mistake. When I copy paste, sometimes these double dashes change to one dash. I don't know why. You need to use more recent tools. Yeah. Going back to this one, it's Cloud Shell terminal. We see I already have it here. Okay, I already have your gcloud functions, call the name of your function, region, Gen2, and the data. And the data that I'm searching on is the same lousy idea that I had. So hit enter, authorized. Almost done right now.
To give us the answer that we got.
Here is the closest match. It has come up with the closest match. We need to understand the abstract in order to see why it picked that particular one up. Alright? So this is as simple as that. This is how quick you can bootstrap your Java application without having to write so many dependencies or everything on your own. And as I said before, the proximity between data, LLMs, apps and APIs empower your ideas, innovation to take off really well. And last thing that I want to leave you with is, it's not just over. The main part is also that you can use Spring AI support for Google Cloud, Vertex AI, Gemini. Why do I say that? Because, see, now we have converted this into embeddings, converted it, did the vector search on the data. But what if you want to get the vector search, ask Gemini a few intuitive questions, and then get a result from that, and then further enhance it to use that data for something else. Right? So you have the Spring AI support for Gemini, which means it supports all of the models. So if your application is built with Spring modules, you can just plug and play it. You're not better locked. You can use any large language model you want, but your code does not change. So that is the advantage of using. And Gemini is powerful, so why would you want to change that with any other model that's out there? So, just long story short, use Spring AI support for Gemini. And one other thing, if you would like to make your applications load or on start really fast, use Spring Native. And I have written a blog about how you can use GraphQL images with Cloud Run to expedite your application startup. Again, that is a 1-hour session on the phone, so I didn't want to focus on it too much. But here's a QR code in case you want to look up how to do that. So that's everything I had, and I hope I don't know if we have time for questions, but I'll be around for like 5 minutes before I have to fly to Sabarokia. So I hope that's all I had. Thank you so much, Amanda. Oh, just one last thing. I have some credits, free Google Cloud credits, in case you want to try this out. It's a $1 credit, but it will at least get you started without having to put your credit card in. So feel free to sign up and try it out.
There was the